well, this is where we really get into the application problems. Now, no, don't worry, it's fine. Okay.
I'm a little scared.
Okay, so I have a bunch of steps here. Obviously, first thing, you have to understand the problem. Okay, often it helps to draw a picture sometimes. You want to basically introduce a variable that you are maximizing or minimizing. Now, we've done this before. We did this the whole first half of the chapter, right? How do you find maximums and minimums? We find the derivative, set it equal to 0. We find critical points, and then we test critical points, or we could also test the endpoints if we have endpoints. Okay? So we're going to have to pay attention to domain. Okay? So this is what Lily was just saying. Critical points, we have endpoints, and then we just want to confirm the result and make sure our answer makes sense. Okay? All right. We're going to start off. The sum of two non-negative numbers is 8. We want to find the numbers if the sum of their squares is as large as possible. Okay? That's going to be a maximum. Right? And then we also want to figure out when this is as small as possible. So that's going to be a minimum. Okay, let's start with the first part. The sum of two non-negative numbers is 8. What do you think? Well, we need two variables, x and y. So sum of two non-negative numbers is 8. Good. So one number is x, other number is y. They have to add up to 8. Okay. So my domain, if it's non-negative, that means the smallest I could have is 0. The largest is 8. Okay, I need a function that represents the sum of their squares. So I'm going to write that as f of x. So if one number is x squared, the other one would be y squared. But I don't want to use y because I want to write this all as one variable. So could we isolate y here? That would just be 8 minus x. So I want to write this as x squared plus 8 minus x squared. Good so far? That's usually the most difficult part of the problem, okay? Coming up with the domain, coming up with an equation. From here, it's going to be extreme value theorem. Okay, what do we do for extreme value theorem? Where's the derivative? So f prime of x is 2x, 2 times 8 minus x times negative 1. All right, don't forget chain rule. Okay. We forgot the chain rule. You could also multiply this all out and then do the power rule. Then you don't have to worry about chain rule. Okay, what do we get when we combine everything? 4x minus 16. Okay, we're going to set that equal to 0. And we get a critical point at 4. Now I know this one is extreme value theorem because I'm just looking for the absolute maximum and the absolute minimum. I don't have to do a number line here. If you want to, you can. It's just not necessary. Okay, it's like the first page of the quiz. Remember the first page of the quiz? Some of you did a number line. It's fine, it's just extra work. Good. So we're going to plug in f of 4, f of 0, f of 8. So remember, we're testing, and our critical point, we should just confirm real quickly, it is in the domain, so we're good. F of 4. So I'm plugging it in here. I'm plugging it into this. So it's just 4 squared plus 4 squared. Okay? So 32. Are we okay with that? What happens if I plug in 0? 64 and 8. Okay, so what are the two numbers that resulted in my absolute maximum? 0 and 8. Okay, so 0 and 8 result in absolute maximum, and what resulted in minimum? 4 and 4. Well, remember, if the one number is 4 and they have to add up to 8, right? Or if the one number is x, the other one would be 8 minus x. So 4 and 4 result in an absolute minimum.
Did you just put it 4, 4?
Sure. Yeah, that's fine. You can put a comma. Good. Okay. Any questions so far? Okay, we're using the same first part. This is just extending to part B. So we still have the sum of two non-negative numbers is 8. So we on the next page we'll still have x plus y equals 8, and the domain is 0 to 8. Good. Okay, this time I want the product of one number and the square root of the other to be as large as possible and as small as possible. So again, we're going to do an absolute maximum and minimum. So let's come up with an equation that represents the product of one number and the square root of the other. Yeah.
F of x equals x times the square root of 8 minus x.
Mm-hmm. Good. Oh. Yeah, so remember, it's the product of one number and the square root of the other, right? So square root of y, but remember,
how do we know the x isn't the one in the square root?
oh, okay, so it actually doesn't matter. Okay, I could do 8 minus x times the square root of x. It doesn't matter, because when we go back and plug in, like, it'll all work out. Now, which one looks easier to solve for? The last one. This one looks easier to solve.
Yeah.
Why? I can distribute this. See, if I take, so if I do, well, yeah, but when I do the derivative, look how if I take this and I, right, think of this as x to the 1/2, if I just distribute, that just becomes 8x to the 1/2, and that's 8x to the first, x to the 1/2. Here, if I tried to do I'd have to do the product rule with the chain rule with a negative 1/2, right? We'll still get the same result. It's just mathematically that one's easier to take care of. Yeah. Okay, what's the derivative? Oops. 4x to the negative 1/2. And 3/2 x to the 1/2. Okay, what is my goal here? I want to find the critical point. So I want to see where this is equal to 0 or undefined, right? What do you want to do from here? From here on out, this is algebra. So you want to do factor out x to the negative 1/2? You can do that. So that will be 4 minus 3/2 x. Are we okay with that? So I get 4 minus 3/2 x over root x. So if I set that equal to 0, well, the denominator, I can't set that equal, like if I try to set that equal to 0, That's an endpoint anyway. It's undefined there. But what else can we do? Set the numerator equal to 0, and we get 8/3. And 8/3 is in the domain, so that's going to be a critical point. Are we okay? Question? Okay, so critical points are technically in the open interval. So I would get x equals 0, but x equals 0 happens to be an endpoint. The endpoint overrides the critical point, if you will. Okay, so it actually qualifies as an endpoint, not a critical point. So critical points are in the interior. If you put x equals 0, I wouldn't mark. Well, if you did it like in the work, I probably wouldn't mark it wrong. But on the AP, if it was like a free response, they would take off if you included 0. Okay, now what do we want to do? We want to test 8/3, 0, and 8. And again, where are we plugging into? We're plugging into f of x. Okay, 8 minus 8/3. 24/3 minus 8/3 is 16/3 times, I don't know what that is. You can plug it into your calculator. It's fine. You could leave it like that. What happens if I plug in 0? 0. What happens if I plug in 8? 0. What's wrong? Question. If you really want, you could change this to a decimal. Yeah. Okay, so this will be my absolute maximum, and 0 and 8 will result in the absolute minimum. That makes sense.
The result.
Yeah, so which one gave us? So 0 and 8 are the absolute minimum, and 8/3 and 16/3 are the absolute maximum. 8 well, remember the other number is 8 minus 8/3. 8 minus 8/3 is 16/3.
Oh, it's just
you just plugged it in.
Yeah. So keep in mind, if one of the values is x, remember the other one is y, which is 8 minus x. So if I take 8 minus 8/3, that's going to give me 16/3.
Wait, but then why did you get that for either?
Well, no, this is the result that told me I was going to have a maximum value when x is 8/3 and y is 8 minus 8/3, which is 16/3.
So it's all
Yes. Sorry, I didn't show it. Is that where we're...
So you plugged in 8/3 with x, and then you subtract it.
Yeah. Are we still confused?
Is that like
Is it because I just skipped step?
Is it one of those steps where you think plug in for x?
Yeah. So listen, the question was asking for what are the two numbers, but what the two numbers are, how did I establish which ones were the absolute max and the absolute minimum? I had to figure out these values. So these are going to result in the absolute minimum. These are going to result in the absolute maximum. And I get the x value. To get the y value, you go back and plug it. Kind of. Okay.
I just don't get why the answer is like that and it's not two numbers.
It is two numbers.
It's like 4.
This and this result in an absolute. So this is my x and this is my y. This is my x and this is my y.
Wait.
Okay. What was the first question asked? We have a sum of two numbers, non-negative, that are equal to 8, right? X plus y has to be equal to 8. So x is one of the numbers, y is the other one. Whatever we get for x, to find y, we have to do 8 minus x. Okay? So we found our critical point was 8/3. We plugged it back into the original function to see what we actually end up with as the result. this gave us our largest answer. These two were both the smallest. So if x is 0, what would y be? 8. So 0 and 8 are my values of x and y that
Why
result.
wouldn't you plug in 8 as well?
Well, what happens when I plug in 8?
0.
I get 0. So do I need to list that another? It's like a
But
duplicate.
isn't it like
It's like a duplicate same answer. 0 and 8 is the same answer as 8 and 0. It's like if I gave you a quarter and then a nickel, you still have 30 cents, but if I
So
give you
when
a
you
nickel
were
and then a
saying
quarter,
that
you
you
still
could
have
write-
30.
if you were
could
saying
graph
you could do Alex asked if you could write it as like 0,8, right?
Yeah.
That's not a point though.
No, it's not.
Okay.
It's just x is 0, y is
But
8.
not like on the graph x and y. Like that is just
right.
but like the variables are equal to that.
Yeah. I mean, listen, if you actually graphed this, okay, if you graphed this and you were to analyze the graph, you're going to see that there's going to be a maximum point.
Oh, those are the two numbers that can be.
Yes, they
one,
can
you
be.
Switch them.
Yes. Okay. All right, let's do one that's a little less abstract, one with an actual geometric picture numbers to it. Okay? Was there another question, Ellen? Okay. All right. We have an open top box. Okay. So we're gonna like fold these edges up. It's gonna be made by cutting squares of side length x. So imagine these squares are being cut out of each corner. Okay. All right. So we're starting with a 10 by 16 sheet of 10. So that means this is starting out as 10 inches. And this is 16. Okay. So we're starting with a sheet of 10. We want to cut out these corners so that when we fold it up, we want the box to hold as much as possible. Okay. That means we want to maximize the volume.
16 is the side with the.
This is 16, and this whole piece is 10. And then what we're going to do is we're going to remove the squares. We're basically cutting away those parts. So we're going to come up with, again, what is volume? Okay, this is a box, so it's just length times width times height. Now, x can be any variable. You can make it a, whatever. But when we write our volume, we want to have it just with one variable. All right. Let's figure out those dimensions. If this is 10 and I take away an x on each end, how much is this? 10 minus 2x. So 10 minus 2x is length. Okay, similarly, if this whole piece is 16 in length, and I cut away an x on each side, this is going to be 16 minus 2x.
Wait, that's not like.
Usually, like, well, honestly, it doesn't matter which one is length and which one's width. So here, I'll have 16 minus 2x. And now the height. Well, I'm folding up, right, this length, which is x. So, okay, so far?
The height.
That's the height, because if we fold this up, remember, think three-dimensional. Fold the edges up, what's the height going to be? X. Okay, before we move on, I want to establish the domain for this. Let's think about well, we need to make sure what is true. We need to make sure that all three of these dimensions have to be greater than 0. Right? So I need to make sure I need to make sure x is greater than 0. I need to make sure 10 minus 2x is greater than 0. And I need to make sure 16 minus 2x is greater than 0. Between 0 and 5, yeah. Right? If it's got to be greater than 0, because see, this will result in x has to be less than 5, and this will come out to be x has to be less than 8. Well, in order for all three of these to be true, remember like when you're in Algebra 1, you graph and you see where they overlap? Where are all three going to overlap? Between 0 and 5. Okay. Which makes sense, right? If I have anything bigger than 5, that's going to end up being a negative measure. Then you won't have bugs. Okay, let me get my notes. I'm going to save some time here. We're going to multiply that all out. What do you think? Can it be inclusive? Okay, so this is different than extreme value theorem. Remember on the last two, we had a closed interval from 0 to 8. No longer do we have, this is not going to be extreme value. This is going to just look for a local minimum or maximum. In this case, we're looking for a maximum. All right, sorry. Let me save you some algebra time. Unless you really want to do it. Here we go. When we multiply this all out, we get 4x cubed minus 52x squared plus 160x. Just reread. Okay, now we want to do derivative. Well, yeah, let's do 12. Again, to save time, I will give you the factored form, which is 4 times 3x minus 20 times x minus 2. Again, I know you can all factor this just to save time. We don't need to do that. Just trust me. Trust me. I've done this problem quite a few times. We want to set this equal to 0. What are my critical points? 20 over 3 doesn't fit. $20 over 3 won't work in my domain. If it was 20/3, this will be a negative measure. So I get x equals 2. It's my only critical point. Now, what were we trying to do? Find the maximum. If I only end up with one critical point, I really don't need to do a number line. But if you feel like I want to just double check, we could do a quick number line to confirm that that's going to result in a maximum. So if I say plug in 1, I'll have negative times negative. And then plug in, let's say 3. Negative, positive, so negative. So confirming quick number line. Notice I did not just plug in values like I did the previous one. Why? It's not a closed interval, okay? When it's an open interval, then we can do the number line. So what do I have? How large should my squares be?
If it was closed, what happened?
You might have to plug in. You would plug in endpoints. Squares are 2 inches by 2 inches. And what is the maximum volume? Oh, I don't know why I put 2, but that's supposed to be 2 by 2. Squares are 2 inch by 2 inch. What's my maximum volume going to be?
You plug it into the original.
Yeah. I mean, listen, we also have this. We can plug it back into the original, right? It's just going to be 6 by 12 by 2. 144 cubic inches. Okay, bless you. What do you think? You have one just like this on the homework, just different dimensions. Okay. All right, 2 more. Yeah, so now you can also see why there's a lot of space for these problems. So give yourself enough space on the homework. Okay, good. We got 2 last ones. We got this. Okay, you've been asked to design a 1 liter. A 1 liter oil can. That's right. Yes, 1 liter is 1,000 cubic centimeters. If we didn't know. Okay, it's going to be in the shape of a right circular cylinder. We want to find the dimensions for the radius and the height that will use the least amount of material. Makes sense, right? We don't want to use the most amount of material. We want to find the least amount of material. Least amount of material, that's going to be surface area. So this time, when I see this, I'm thinking I want to minimize surface area. So again, when you're doing these word problems, try to look at what words are used. Because whatever I'm minimizing, that's the equation I want to take the derivative and find the critical points. Well, so if it said like maximizing how much fits in it, that would be a volume. But when we're talking about the actual material, that's the surface area. Okay, I gave you volume and I gave you surface area. All we know here is what? Volume is 1,000 cubic centimeters. And I know my surface area is the one I want to minimize. Okay. So I want to do the derivative of this, but I have too many variables. I want to either get rid of H or get rid of R. Okay, I know volume is 1,000 and volume is pi r squared H. Has to be equal to 1,000. So I'm taking my volume formula so I can isolate one of the variables here and plug it in here. Does that make sense? Okay, now I'll tell you it doesn't matter which one you do, but there is one that makes it easier. H is the one I want to isolate. So H is going to be 1,000 over pi r squared. Okay, so that means this is going to be okay. So now I have a function in terms of r. So we are going to minimize the radius. Now this is, I didn't address the domain here, but this one's kind of strange. Just the domain in this case, it's just anything greater than 0. Because you can adjust the radius and the height. You can make a decimal form fraction. Well, honestly, if you forgot the domain completely in this problem, you'll still get the same answer. So, yeah, you'll get the formulas. Okay, what do we have here? So, we have 2,000. I'm going to write this as r to the negative 1 plus 2 pi r squared. Just to make it easier to do the derivative. You don't want to do a quotient rule or anything like that. How did I do that? I multiplied 2 to the 1,000. Oops. I canceled out the pi's. And this is r to the first. And there's an r squared. So instead of making it 2,000 over r, I just made 2,000 r to the negative 1. Okay, now we do the derivative. So negative 2,000 r to the negative 2 plus 4 pi r. What do we want to do? Set this equal to 0 and solve for r. So maybe I'll move this over here. Oh, we can do like a cross multiplying.
Wait, don't you just have the whole thing?
I set the whole thing equal to 0. Listen, I could do some fact. From here, it's algebra. There's so many different ways I could solve this equation, right? I could factor out r to the negative 2, or 4r to the negative 2. I think that's what we did in the other class. R can't be 0, so we can just cross multiply here. And what do we get? Q. So yeah, if I, what do we have? 4 pi r cubed is equal to 2,000. So r is going to be the cube root of, well, what's 2,000 divided by 4? 500. I don't know what this is. Whatever. I don't remember. Somebody have a calculator handy? I think it's like 5 point.
No. Oh, because you remember.
I just taught this last period. I don't.
I like 3 decimals. 5.419.
How did you?
419.
That changed.
Okay. Okay.
So that's it.
That's it. I just need to find my.
Oh wow.
I need to find the height. Listen, this one we could also do a quick number line. So if I did a quick number line,
Wait, can you plug it into 1,000 over pi r squared equal to h? There, that one. Find the height.
yes, that's what we're going to do. Yeah. We're going to take this and plug it back in here.
So why
But
not?
this one, if we tested this, we will see that's going to minimize. Okay. Height, we're going to plug that into the 1,000 over pi and then r squared. And I think 10.38. Alec, do you have your calculator? I don't remember.
Wait, it was like 544 for surface area.
No, for the height.
Oh, the height.
Did you find the height?
I didn't have that.
But don't use the rounded number. Use the exact number.
I like 10.38.
I don't remember.
don't
I can literally just click back over to my other.
Someone has it.
Somebody have it?
No, but now, because you're using.
Don't use the
The
rounded
rounded
number.
No, I'm not using it. 10.8385.
838.
49. So you're trying.
Okay, and they actually didn't ask for the surface area. They just wanted the dimensions. Okay, last one. Okay. What makes this difficult is each problem is like a completely different situation. Okay. Sometimes we're working with area and perimeter. Sometimes we're going to work with.
Would these be FRQs?
Yeah, these would be. Well, some of them would. Or they might. This would be part of an FRQ. Okay. All right, here we go. Rectangle is to be inscribed between this curve and the x-axis. So I don't know exactly where it's going to go. I'm just going to sketch a little rectangle here. Okay. Now, I don't know. I need to be able to express the area of this rectangle as a function of x. Okay.
Wait.
There's a rectangle here. I'm trying to fit this in here. My goal here is to get the biggest rectangle that I can fit under that curve. That's what I'm going to do here. I want to maximize the area that's going to be inscribed. But I first have to come up with a formula. Okay. We don't know what this distance, we don't know exactly where. It could be at 2, it could be at 2.3, anywhere between here and here. What would that domain be? Well, we're
2 to 3.
let's be a little more precise here. Okay.
Very precise.
If this is our parabola, can we figure out where it's going to intersect the x-axis?
Set it equal to 0.
Set it equal to 0. And what do we get? Root 12. Right? Add this, multiply by 2, square root. Are we okay? All right. Now, x is going to represent this. No, and I'll explain why. We don't want plus or minus. X is the distance from here to here. So we're solving for a value of x. X is just the measure from here to here. Do you agree? Like, take any graph, right? And I said, okay, what is that? That's the ordered pair x comma 0, right? Like I don't know. And if I made a rectangle and it was symmetric, then the base of that rectangle would be 2 times that value of x. Does that make sense? So here, my base, oh. Okay. All right. Okay, now I need to figure out what's the height of that rectangle. Well, my height is always whatever y is equal to. So height is equal to y, but what's y equal to? 6 minus 1/2 x squared. All right, so what is my area formula? Base times the height. Now you could also multiply it out, but if you're just writing the formula, you can leave it like this. Obviously the next part, when we do the dimensions to maximize the area, it's gonna be easier probably to multiply it out rather than do product rule. So let's do that. Oh my goodness. So before I do derivative, let's make this 12x minus x cubed. All right, that gives us 12 minus 3x squared. Now what? Set it equal to 0. So what do we get for our critical point? Plus or minus 2. Because I originally made my domain from positive 0, so it's just going to be positive 2. Positive 2. Okay. What are the dimensions that will maximize the area? What's the base? 4. And I didn't give you units, so I'll just put 4 units. And what's the height? 4. And what's the area? I mean, it's not a trick question. Yeah, 4 times 4 is 16.